Okay, hello there, students, and tonight we're going to be speaking about differentiation rules. And last weekend we dealt with the formal definition of the derivative, and we had two different forms, the formal definition and then the alternative version, as you have in your notes. And now we're going to be talking about the basic rules to find the derivatives. And so we're starting off with f of x is equal to c, and g of x is equal to x to the n, where n is a positive integer, and those are the building blocks from which polynomials and rational functions are constructed. So we have, to find the derivatives of polynomials and rational functions efficiently without resorting to the limit definition of the derivative, we must first develop formulas for differentiating these basic functions. So when we look at this, we have the constant rule. If f of x, and you got to in math remember that a lot of what you are reading is, well, there's so many conditional statements, if this then that. So if f of x is equal to c, then f prime of c is equal to 0 everywhere. The derivative is 0 because it's a horizontal line, so the slope is 0. Alternatively, we may express this rule as the derivative of c is equal to 0. Okay, so if I say to find the derivative of g of x is equal to 3, then we would say g prime of x is then equal to 0. And we could say the derivative with respect to x is 0, but that's good enough like that. So the slope is 0. And this, like I said, it makes sense. We're talking about a horizontal line. Y is equal to -3. Of course the slope is 0. It's horizontal. Then we have the power rule. So let n be a positive integer. If f of x is equal to x to the n, then we have this one, f of x, f prime, is equal to n times x to the n minus 1. So now one of the things I tell students right off the bat is just like this comes down or out front, and then the exponent drops by 1. Alternatively, we can use it's like the Leibniz donation but with notation, but ddx means we're going to take the derivative with respect to x of x to the n. And again, you see that n come out front and the exponent drops 1. So on both of these examples, there's an extra video that you could watch with this, but what you would have is x prime of x is equal to 7x to the 7 minus 1 power. So you get f prime of x is equal to 7x to the 6th power. So the derivative drops a power, okay? All right, then we have the sum and difference rules. The sum and difference and constant multiple rules. So there's a lot of things that I've said to you in class where we have the limit of a sum is equal to the sum of the limits. And the same thing is going to hold true here. Let f of x and g of x be differentiable functions. You can take the derivatives and they have a slope that exists, and k be a constant. Then each of the following equation holds. You have the sum rule and you have a difference rule. You have the constant multiple rule on this page. So the sum of the derivatives, as you take the derivatives of f and g, it's equal to the derivative of f plus the derivative of g, going left to right. And you see that sometimes we write it like this. There's the sum, and we have the derivative tick mark on it, and that's equal to f prime. And that's how, notice I said f prime. I said that last week as well. F prime is the same thing when you see this. We'll say f prime of x. Sorry, I guess I should have added that. F prime of x. Okay, so g prime of x. It's the derivative of f with respect to x. So you have the difference rule there. The derivative of the difference of a function f and a function g is the same as the difference of the derivative of f and g. So you have those, and then the constant. I would probably make sure you're very comfortable with these. And then the constant multiple rule is the derivative of a constant k multiplied by a function f is the same as the constant, oops, I have a misspelling there, multiplied by the derivative. Okay, so what happens is this k can come out front, and you can just multiply the derivative of f by that. So passing that out front. And then the same notation down here. Okay, there's a video here, if you will, also. And then we have example. And for this example, we have g of x is equal to 3x squared, and compare it to the derivative of x squared. So we have g prime of x then g prime of x is equal to 3, so keeping that constant in there, times 2x to the 2 minus 1. Oh, sorry, kind of sloppy there. Here, let me fix that. Okay, so that's equal to 6x to the 2 minus 1, which is just 1. So we have 6x here. And then the derivative of f of x is f prime of x. So we'll bring that exponent around front. We get 2 times x to the 2 minus 1 power, and that would be equal to 2x. So you can see that they differ by a factor of just 3, and that's that constant. Let me see if I can fix that. Okay, I'll have to leave that go. So find the derivative of the f of x. Now we can use this idea of the sum rule. If we want to find the derivative of f of x, we'll just say, all right, we'll go left to right using the sum and difference rules. And we have then f prime of x is equal to 2 times 3x to the 3 minus 1 power minus 6 times 2x to the 2 minus 1 power plus, then the derivative of a constant, remember, is just 0. So we can simplify that. Then we can say this is 6x squared minus 12x. Okay, and there you have it. There it is. There you go. Okay. All right, and let's move on. So we have another video that you can watch, and the question says find the equation of the tangent line. So we want to find the equation of the tangent line to this graph. So again, there's a video, you can watch that if you like. I'm going to just go ahead and do this example. So we have the first thing. Oh, let me backtrack a little bit. You have a function and you want to find the equation of the tangent line, and you kind of know what this looks like. It's, you know, a U-shaped graph. And the vertex is equal to, let me see, the x value would be negative of -4 over 2 times 1, right? So it's going to be a 4 over 2. It's going to be 2, and you're at 1. So that means I'm on the left side of this, something like this, okay? And it's not important that you know that. I just wanted to kind of get an accurate drawing. So I'm going to expect this to have this tangent line to have a negative slope. Now, I could be wrong. I've been wrong once today. So if you look at it, you can put 1 in there. You get 1 squared minus 4, which is -3. -3 plus 6 is then 3. So 1, 3, right? Hope it's right. Anyhow, so the first thing I want to do, if I want to find the equation of the tangent line, I kind of begin with the end in mind, and I'm thinking, okay, why don't I put my answer somewhere convenient? I'll say y minus y1 is equal to the slope of the tangent line times x minus x1, okay? And in this case, I know that the x is 1, and I should really check myself because I want it to be correct. So it's going to be 1 squared minus 4 times 1 plus 6. And so I get 1 minus 4 plus 6, which 1 minus 4 is -3 plus 6. It turns out to be 3, so I was correct. Okay, so we know that f of 1 is 3. Okay, so here we go. So in the end, I've got this. I've got y minus 3 is equal to, I need the slope of the tangent line, but I know that everything else is ready to go, and I just need to fill in that blank here. So that is the slope of the tangent line. So the slope of the tangent line is then equal to f prime of x. So f prime of x, well, actually, it's not. The slope of the tangent line is always going to be f prime of x, but at this point, 1, 3, it's going to be something a little different. I'll show you then. So we get 2x minus 4, right? Now, that's pretty quick, right? You bring the 2 out front, drop the exponent 1, and then the derivative of 4 would be 4x to the 1 minus 1, which is 0, so it's just going to be x to the 0 is 1. Okay, so now, then we want this. F prime of 1 is equal to 2 times 1 minus 4. So then that turns out to be equal to f prime of 1 is 2 minus 4, which is equal to -2. So now we have the slope. Sorry, my pen is writing a little sloppy. course, it has nothing to do with the writer. Okay, so let's get that in there. And then, so we now have our equation. I'm going to bring this over. And all we have to do is plug, we want the equation in the tangent line, so we could just plug that in, -2 for the slope. And there you have it, because we know. Now, a good thing to do if you're not sure, I'm going to write this as y is equal to -2 times x minus 1, and then I'm going to add 3 to both sides. So find the equation of the tangent line to the graph. There it is. There you have it. There you go. Okay, now that's in sort of like a point slope form, but you could write it however you think you need it, or if you want like y is equal to -2x, I think plus 5. So that would give it to you as well. Okay, so first thing I need to do is to think about what is f of 1. That gives me the point on the graph, so I did that. Actually, the first thing I did is I thought, oh, what is this graph? What does it look like? Just to give me a picture. Sometimes a graphing calculator will help out with that. And the second thing I did is I thought, okay, I need a point on the graph to get a tangent line. I need the equation of a line. And that I kind of thought of here. And then I thought, okay, well then I need, the third thing is I need the slope. The slope is the derivative. Once I get that, then I can plug in 1, and I'm all set and ready to go. There's my equation. Okay. Again, there's another video here that you can watch if you need to, but use the figure below to indicate the derivatives. Okay, now you're looking at this and you're thinking, what in the world are they looking at? Okay, so if I scroll a little bit more, you'll see. So I've got f of x and a g of x is dashed, right? So now you have to know that h of x is equal to f plus g, right? And you're seeing a dash line, but it must be continuous. I think they just did that. I'm not sure I'm liking that they did that, but I'm going to put it in a different color instead, but I'm going to connect it because in order to be differentiable, the function must be continuous. So I'm thinking that probably wasn't a great idea to do a dash line, but I'm going to make it solid there. So we're going to use the figure below to find the indicated derivatives. So we have h of x is equal to f plus g. So I want h prime of 1. So I'm going to start off and I'm going to write this expression. H prime of x is equal to, using the sum rule, we're going left to right. Okay. And so now to find h prime of 1 is just going to be f prime of 1. I can plug in, as long as it's defined, plus g prime of 1. So if I look at f prime of 1, here's 1. So you are looking at finding the slope of f. So on this interval, in fact, let me use a different color. On this interval, f looks to have a slope of -1. So we're going to plug in -1. Because remember what we're doing, we're saying the slope at 1 on f. And then I'm going to choose a different color here. And I'm going to highlight this because I think I'm going to use that as well. Okay, so now g prime of 1 is right here. And it looks like that we have a slope of 1 there. And, you know, if you go up and over, rise over run, here we go, rise, -1, run, 1. So remember, that's a slope of -1 over 1. Same thing here, 1 over 1, 1. So it looks like h prime of 1 then is equal to 0. So we have our first answer here. And then we have h prime of 3. So we have h prime of 3 is equal to f prime of 3 plus g prime of 3. So now I got to look at where 3 is. So g, that looks kind of funky there. So if I'm looking at h prime of 3, h prime of 3 is the sum of both f prime of 3 and g prime of 3. So g prime of 3, or let's do f prime of 3. F prime of 3, I think we have a problem there because the slope here does not exist. So the slope at this point doesn't exist because, remember, slope is a limit. And as you come in on the left and the right, it's not going to have the same slope. On the right-hand side it has a slope of 1, and the left it has a slope of -1. So there's a problem here. And then plus g prime of 3 is, of course, going to be 0. But I want to be clear about this. F prime of 3, if we were talking about the approaching from the left, it would work. But I'm going to say the slope does not exist. Okay, now I'm kind of interested in what they're going to say on their video. I think I may just play it before I make the second video now. Okay, let's try h prime of 4 is equal to hf prime of 4 plus g prime of 4. Going back to look at the graph. So at 4, it looks like on f, the slope is 1, plus on g prime of 4 up here, the slope looks to be 0. Remember, it's a horizontal section there, so I'm going to say it's 0. So I'm going to say that overall h prime of 4 is equal to 1 there. Okay. Here I'm going to say h prime of 3 does not exist as the sum. Both f prime and g prime have to exist. Here, f prime of 3 does not exist. Okay. All right, so that's enough for there. I'm going to do one more, and then I'm going to wrap this one up. So with the product rule, let f and g be differentiable functions. Then if we have the derivative of a product, f times g, it's equal to the derivative of f times g plus the derivative of g times f. So if I did this, sometimes we do it real quick like this, f prime g plus g prime f. Okay, and the second rule is saying the same thing. This means that the derivative of a product of two functions is the derivative of the first function times the second, the derivative of the first times the second function plus the derivative of the second times the first. So now this kind of says it differently. The derivative of the first function, right, times the second function, g. Okay, so if you can get this, great. It's the sum f prime g plus g prime f. And sometimes I say first derivative of the first, der first, second, plus der second, first. But whatever helps. Let's try one of these. And there was a video in here for you to watch. I'll have to make sure that you get the video link for that. So j of x is equal to f of x times g of x. Oh, I think I am just going to do that. So I always, as a student, I always wrote it down. If I wanted g prime of x, it's equal to f prime of x times g of x plus g prime of x times f of x. Okay? And you want to find j prime of 2. J prime of 2 is equal to, I'm going to write it out, f prime of 2 times g of 2. Everywhere you saw x, j prime of 2, the derivative at 2, you're going to replace x with 2. Okay, so then what do we have here? We have values that are given if f of 2 is 3. So f of 2 is 3. F prime, I'm going to start over. F prime of 2 is -4. So I'm going to put this in -4 first. And g of 2 is 1. So I'm going to -4 times 1 plus g prime of 2 is 6. So it's going to be 6 times f of 2 is 3. So we can add these together, -4 plus 18. And it turns out that j prime of 2 is equal to 14. So the slope at x is equal to 2 is equal to 14. Okay, on the graph of j, which is the product of two functions. For j of x is equal to this product, let's go through one more. So we have j prime of x is equal to, now we have the derivative of the first. Here's the first, here's the second, all right? So we'll say f prime, that's our f prime if I do it like this. If I say f of x is equal to x squared plus 2, and then g of x is equal to 3x cubed minus 5x. So I'm going to do it like this. F prime of x, just g of x, plus g prime of x, f of x. And that way it'll stay a little straight for you. All right, so we will find j prime by applying the product rule. Here we go. J prime of x is equal to, we're going to take and find f prime, so that's just going to be 2x. And then g prime of x is going to be 27 x squared minus 5. So now these might take a little time getting used to using the derivative, but I don't think that much time. G of x, so I need to put in 3x cubed minus 5x plus g prime of x is 27 x squared minus 5. Put that in there. I think I'll move this all over. And then we need f of x is x squared plus 2. At any time, pause the video if you want to check to see how I got the videos or what I'm putting in here for the product rule, okay? So let me see. So use the product rule to find j prime of x, okay? I'm just checking over my work. I think I might 3x cubed. So it would be 9. I think I said 27. I've got a mistake here. Let me go back here. That's 20. I have 27. That's going to be a 9. 9x squared. Sorry about that. I was looking over. I thought something is not lining up right. Okay, so 9x squared, because looking at 3x squared minus 5x. Here we go. Sorry about that. Okay. All right. So then we have g prime of x. And sometimes, I mean, there's not really a whole lot we're going to gain from multiplying this out, but we can multiply it out. And we would then have to multiply the partials together, and we would have some time in there, but it's not that bad. I'm just going to give you the answer so I can keep this video a little bit shorter. And that's what you should end up with. So j prime of x would turn out to be that after you compute your derivatives. Okay? Alrighty. Then, let me see. I'm going to take a break. I'm going to come back for that last problem, number 3 there, or the next problem, and I'll pick up on part 2, 3.3 part 2. Okay? So, I'll be right back.